Discoveries made by the James Webb Space Telescope revealed that everything we knew about the nebula NGC 1514 was merely superficial. Although astronomers have been studying it since the 18th century, it was JWST that finally brought its true nature into focus, and now, the data we have no longer fits within any of the conventional models. But out of hundreds of known objects, why did this one turn out to be so radically different? The gas and dust ejected by the dying star at the nebula's center came into full focus. Before, we could only make out a soft halo, but now, a tangled web of fragments, ruptures, and ring-like clumps. In some areas, it looks like something punched through the shell, faster-moving material breaking out from within. This is what stellar death looks like, if you're seeing it in infrared. But where does all this instability come from? What triggered it? Before Webb, we couldn't even detect most of this material, let alone observe it this clearly, says Mike Ressler, project scientist for Webb's MIRI instrument. Webb's images didn't just sharpen the view, they showed that the nebula's very structure defies our expectations. The rings aren't symmetrical, the contours are warped, and there's no clear logic to how the material is spread out. How could something like this even form? And why haven't we seen distortions like this in other nebulae? For many astronomers, it came as a shock. These observations aren't just visually stunning, they force us to rethink how massive stars die. We can't rely on the old textbook diagrams anymore. NGC 1514 breaks them. But how do we even begin to make sense of this chaos? What's really behind the rings, the fragments, the ruptures? To figure that out, we need to dive into the true nature of this nebula. To really understand the nature of this strange structure, we first need to figure out what this nebula actually is. NGC 1514 sits in the constellation Taurus, about 1,500 light-years from Earth. It's what's called a planetary nebula, a shell of gas and dust, ejected by a dying star in the final stages of its life. Since William Herschel first spotted it back in 1790, this one stood out. He couldn't resolve its light into individual stars, it just looked like a cloud. And he was right, it really was something different. But why does it still remain a mystery? At the very least, because it doesn't look like any other nebula we know. Today, thanks to JWST, we're seeing its actual shape. It's not a sphere, not a ring. It's something closer to an hourglass, with the ends chopped off. The nebula is tilted about 60 degrees, and its contours pinch inward at the waist into V-shaped forms, right where the dust gets denser, as if something squeezed it from both sides. But what could have caused that kind of distortion? Why does it look less like the result of an explosion and more like something was shaping it? You'd expect the rings to be smooth and symmetrical. But here, it's the opposite. Blotchy, clumpy, with thick spots and nearly transparent ones. The dust doesn't spread evenly. It creates a texture that feels more like internal instability than natural expansion. So could it be that this nebula wasn't shaped by something external, but by itself? Could a dying star warp the space around it just because it lost balance from within? If that's the case, then we need to take a closer look at its very core. One of the strangest forms ever captured by JWST doesn't just call for a surface explanation, it demands we understand what shaped it from within. At first glance, the center of NGC 1514 looks like a single bright star, but that's just an optical illusion. In reality, it's a binary system, two stars orbiting each other in a stretched, narrow path, completing a full rotation roughly every 9 years. Webb sees them as a single point because they're so close together, but it's their interaction that may be the reason for all the chaos we're seeing on the outside. Could that really be the case? Could a pair of stars create a structure that simply doesn't make sense when you assume a lone star is behind it? One of them, in the past, was several times more massive than our Sun. When it entered the final stage of its life, it began shedding its outer layers in slow, dense, layered outbursts. The star basically bloated, losing itself piece by piece. But it wasn't alone. Right there beside it was its gravitational partner, and he got involved. When this star was at the peak of losing material, the companion might have been extremely close, says astrophysicist David Jones. When two stars orbit too tightly, their gravity starts interfering with the way material gets ejected. The outflow becomes directional, uneven, twisted. Matter starts spiraling, crossing itself, and instead of forming a smooth sphere, you get rings, voids, jagged fragments. That explains the nebula's shape, but only on the surface. Beneath all that complexity, there's a strange sense of emptiness, like something's missing, not visually, but conceptually. The material isn't just unevenly spread, it seems to avoid certain areas entirely. There are regions where matter should be, but it just isn't. And in those gaps, it's not the lack of mass that hits you, it's the absence of meaning. It's like we're not looking at a finished object, but at a fragment of something bigger, something lost or erased. We're not just seeing a nebula. We're seeing the gravitational scars of two stars locked in a cosmic struggle, frozen in space. But even that doesn't cover the whole story. Why is the chemical makeup of NGC 1514 so different from other nebulae? Why is it missing things that should always be there? What exactly is hiding in its empty zones? And why, in this case, does emptiness say more than presence? When scientists looked deep into the structure of NGC 1514, they expected to see the usual suspects: heavy elements, carbon, complex organic molecules. All the stuff a star typically throws off when it dies. But JWST revealed something else entirely. Dust, present, oxygen, present, but carbon, nowhere to be found. And with it, polycyclic aromatic hydrocarbons, or PAHs, complex carbon-based molecules that usually wrap around dying stars like smoke from a fire. This wasn't just unusual, it was an anomaly. PAHs are considered standard in planetary nebulae. Their presence usually confirms that the star went through all the typical stages: accumulation, heating, ejection. Without them, it's like part of the script just didn't happen. So why is this case different? Astrophysicists suspect it all comes back to the binary system. When two stars orbit too closely, their paths literally churn the ejected matter together. And in that turbulence, complex molecules simply don't get the chance to form. The star dies, but not by the rules. And for the first time, JWST lets us see that. One more detail: because there's no carbon or PAHs, the light from the central stars travels much farther than it would in a typical nebula. The dust doesn't block it. That's why we're seeing these thin, ghostly rings stretching way beyond the main structure. And along with that, emptiness, in places that are normally filled in. But could that emptiness be intentional, part of the design? Or are we just witnessing the breakdown of structure at a level we've never been able to detect before? And here's the real question: if the basic nature of this nebula is broken, does that mean we still don't fully understand how stars die? We're used to thinking of a star's death as the end: an explosion, dust, rings, a white dwarf, all predictable. But NGC 1514 breaks that model, not because it looks different, but because it acted different. Every part of it is distorted. The rings are asymmetric. The molecules never formed. The light stretches way too far, and all of it has been captured by JWST, which, by its very presence, reminds us that even the things we're sure about might not be fully understood. JWST didn't just take a photo. It cracked the structure open, and it showed us that what once seemed clear is actually a thin shell, hiding chaos, incompleteness, and internal conflict. This isn't the kind of discovery you sum up in a paragraph. It's a crack in the system, a fracture where something new is starting to leak through. And if even a so-called standard object like a planetary nebula turned out to be this different, what else do we treat as normal, simply because we've never been able to look deeper? Maybe JWST hasn't revealed the full picture yet. Maybe it's only just begun, and the most mind-blowing cosmic secrets are still ahead of us.